Good morning, everyone. Thank you for joining us today. My name is Marta Fernández de Alarcón. I am the Secretary General of the Spanish Business Council, and I want to welcome you to this webinar about how Spanish companies can spearhead the achievement of KSA's 2030 goals, with three of our members of the Chamber, ACCIONA, INDRA, and SENER, all of them leaders in this industry. Thank you, all of you, for your support and collaboration. And I am delighted to present today for this webinar these three amazing experts. Julio de la Rosa, Water Business Development Director at ACCIONA Middle East. He will introduce different aspects about the achievement of KSA's 2030 goals. Liliana Velasco, Experienced Manager of Integrated Water Management at INDRA. She will talk about Oblysis, energy efficiency in wastewater treatment. And Salvador Muñoz, Water Treatment Processes Engineer at SENER. He will talk about the efficient and sustainable desalination. The Spanish Business Council, as you may know, is an international community. And we always try to work with all our members, with Spanish companies and non-Spanish companies. And one of our main purposes is to be a platform where all the members can share ideas, can make networking, to find collaborations, and to make businesses in the UAE. So I don't want to waste time to our speakers. Let's start. At the end of the webinar, we will explore a Q&A with all the speakers. Okay. So thank you, and let's start.
Good morning to everyone. My name is Julio de la Rosa, Development Director of ACCIONA in the Middle East. First of all, I would like to thank the Spanish Business Council for hosting us, and to congratulate for the amazing work that they are doing here in the region, not only in Emirates now. And as well, thank you very much to the audience. And I hope I'm gonna be straightforward, and I hope the presentation I'm gonna deploy is something of your interest. Okay, now I assume you can see it perfectly. So my presentation has only 3 points. I'm gonna be very brief, and I'm gonna try to explain to you why we do consider ACCIONA is helping Saudi in getting the 2030 vision. And it's very simple. It's first of all, it just wasn't. We only do sustainable projects, implementing the most efficient technology for water projects. And this is helping the country to achieve the Saudi Vision 2030, but not only that, as well the Saudi Green Initiative. As well, we are contributing for the country to reach the goals in the National Water Strategy, and as well the NITACAT objectives that are defined with the local and Saudization content. And how we do this? With the projects that we are developing here in the country. Right now, in the last 6 years, we have got 10 projects. That is not only 10 projects, but 18 contracts, because in some of the projects, we are not only the EPC contractor, but as well we are investing, we are providing equity, and we are taking loans to develop 4 out of the 10 projects that we are doing here in the kingdom. We have developed 6 desalination plants, 2 units in Al Khobar in Daman, 2 units in Shukeik, and 2 units in Jubail, one of them for Marafi. This is taking the total desalinated capacity of ACCIONA today here in the kingdom to 2.3 million cubic meters per day capacity. This is able to provide potable water to 9 million people here in the country, more than 25% of the population. Many things have been said about the sustainability of desalination in the last months and years, and I can assure you that today the desalination plants that are implemented by ACCIONA is either neutral or positive CO2 plants. First of all, many things has been said about the brine. For you to know, before we decided to go ahead with any desalination project, a really detailed recirculation study is conducted before defining the point in which we take the water and where we deliver the brine. We are incorporating renewable energy. We try to fit as much as possible the plant with renewable energy, mainly PV. We develop our local relationship with the local suppliers as much as possible. We incorporate Saudi national to the project as much as possible, and always fulfilling the legal requirements. And always we incorporate new technologies to all these projects as much as we can. And where is taking us this? we're stating that we are able to provide potable water in an amount, quality, reliability, and affordability price as much as possible. And as well, you can see at the bottom part of this presentation, I referred before to the renewable part of the desalination plants. Today, in let's say average desalination plant developed here in the kingdom, this is, if we consider this rectangle as the 100% of the plot that we have for any desalination plant, what is purely the desalination units is around 35% of the area of the plot, while the photovoltaic part is around 65%. This is what is allowing us to provide between 30 to 50, depending of the plant, of the total energy consumed by the desalination plant through renewable energy. So we have sustainable water, potable water, not only for the urban, but as well for the industrial uses. We said that we incorporate new technology, but this is not something that we said just for saying something. It's something that is recognized worldwide. We got the Global Water Award for the distinction from the Global Water Award for the digital twin that we implemented in Hobart 1. A digital twin is a digital replica of the asset that we are about to construct. And this digital replica, what is allowing us is to simulate how the asset will work. And this will allow us to optimize the consumption in terms of chemicals and energy of the asset. As well, we develop the relationship with our local Saudi partner, in this particular case, Saline Water Conversion Corporation, and we have a very close relationship with them for renewable and new technology. Even they are paying visit to our facilities in Spain to strengthen the relationship. This is for desalination. What about sewage treatment plant? We have provided investment, we have provided the money needed to develop 3 projects here in the kingdom, one of them in Medina, 200,000 cubic meters per day capacity, another one in Buraida, 150,000 cubic meters per day capacity, and another one in Tabuk with 90,000, totalizing 440,000 cubic meters per day capacity of sewage treatment plants here in the kingdom, able to provide sanitation to 1.6 million people. And this is maybe the most and the perfect example of circularity and sustainability in a water project. This is that we take the raw sewage that you have at home or in any industry, we treat it, and we get treated water and sludge, and we sell this to the farmers to make the irrigation for the crops, for the food, for the greenery in general. And as well, we provide to them the sludge as a fertilizer, natural fertilizer. So with this plant, first of all, what we are doing is to avoid the use of fresh resources for irrigation, and at the same time to reduce the use of, let's say, traditional chemical fertilizers. As well, this plant is fed again through photovoltaic and the biogas produced in the plant itself through the methanization of the sludge that we produce. So this project, as we said before, is the perfect example of us, let's say, net zero project and supporting the circular economy. And this is why this was the first green financing project. What is a green financing project? If you present to the, let's say, the financial institution a project that is fulfilling some of the United Nations Sustainable Development Goals that this project is doing, and you can assure that every single dollar that is invested in this project is allocated to a sustainable project, you can call to a second party opinion, in this particular case, ISP Global, to certify all this, and you can have access to what is called the green financing. More and more investor and Saudi itself is promoting this kind of project. More funds are available for green financing projects that at the end of the day, more availability means cheaper money. And the last project I would like to present it to you is the South Cluster project that we are doing in Saudi Arabia. This is in the region of Baja, Sir, Narjan, and Jassan. This area is equivalent to the half of Spain for 5 million people. And what we are doing is helping the national water company in the transition to a pure public entity to a pure private entity, providing optimization in the 59 water treatment plants that they have, the 43 water treatment plants. And the most important thing is implementing more efficient management skill in the whole water cycle. So, okay, this is what you are doing, but why you consider that this is helping to the achievement of the 2030 goals? Okay, let's have a look to the Vision 2030 under the PIF program. PIF is the Saudi Fund for Investment. It's the National Pension Fund of Saudi Arabia. The target that they have is divided in 3 levels. Here I'm showing only 2. And which are the targets? The target is to grow and diversify the economy. ACCIONA is investing. To increase the employment. ACCIONA is employing people here in the kingdom. To contribute to the growth of the private sector by providing potable water beside the investment that we are doing. By providing potable water, we are helping the industry to grow. Maximize the value capture from the energy sector. We are implementing renewable energy. Unlock and grow the non-oil export. The water sector itself is a pure non-oil sector. And further integrate the Saudi economy regionally and globally. We are helping, we are investing, and we are developing the economy of the country. So we are as well helping to this target. The Green Initiative. The Green Initiative basically consists in increasing the number of trees in the country from 10 million trees in 2021 to 600 million trees 2030. And those trees need water. From where is coming the water? In part from the sewage treatment that we are developing. We mentioned 3 locations, Tabuk, Medina, and Kasi. And in these 3 locations that we have the sewage treatment plant, within this Green Initiative in Saudi Arabia is the increase of the number of trees significantly. That is going to be fitted. This is the model. The model is at the top of the picture. You have the traditional sewage treatment plant, and at the bottom you start with this greenery and this development of tree zone with the use of only reused water. This is a mock-up that you can saw in the COP28 happening today in Dubai. As well, we saw that we are helping to the national water strategy. Which are the objectives of the national water strategy? To ensure the continued access to adequate quantity of water. This is exactly what we are doing with our water plants. To improve how you manage the demands and the supply. Exactly, this is what we are doing. Deliver a cost-effective and high-quality water under an affordable price. Exactly the target of our water treatment plants. Safeguard and, let's say, be sustainable in the use of water. This is exactly what we are doing. We are providing treated water, and we are, let's say, saving the use of, let's say, fresh water that is always more valuable. And as well to ensure the competitiveness and effectiveness of the water sector. Exactly what we are doing in the South Qatar. We are helping the Saudi Water Authority to implement more efficient management system. And in short, as well, this is within the national water strategy. They want to shift from the use of non-renewable groundwater. This is the, let's say, just to avoid to finish with the underground water available, and they need to increase the desalinated water available in the country. And this is what we are doing with the desalination plant that we are developing here in the country. As well, local content and Saudization. Saudization means the employment of Saudi nationals, and localization means the use of local suppliers and companies. For example, more and more the requirements are higher and higher. Right now, for example, in the operation and maintenance of any water plants here in the kingdom, the requirement is during the first year is 70% of Saudi nationals, and from the year 7 onwards, 90%. And we are fulfilling this. As well, there are some requirements to incorporate local companies for doing the operation and maintenance of the water plant. Right now is around 30%, and for sure we are fulfilling this objective. And as well, more than 50% of the supply to be implemented in any project here in the kingdom to be 50% local. And we are fulfilling this. And this is not something that we are just saying, but something that we are showing to the market. This is the event in which ACCIONA launched the Fresh Graduate Program, through which we are going to take young, fresh graduates in the universities of Saudi Arabia, and we are going to incorporate them in our projects. And that's all. Thank you very much to you all. I hope it was of your interest.
Thank you. Okay. Thank you, everyone, to connect to my presentation. This is Liliana Velasco. I am the business development manager in INDRA. Today, I want to talk about operational energy efficiency of the wastewater treatment plants. I'm going to talk about the technology of Oblysis. This is a new technology that we are implementing different wastewater treatment, and I'm going to talk about our opportunity to improve the energy consumption and operational costs. But before I want to talk about INDRA, INDRA is a technology IT company. We are developing different technology for different sectors. we are focused in energy sector. We develop technology for oil and gas, electricity, and the water sector. What we are looking or what we are working in the water sector, we are develop technology to help the different companies to the digital transformation. Today I'm going to focus in operation plans. What technology we are developed for the wastewater treatment plants. Okay, Oblysis. Oblysis is technology that is focused in transformation of the plant. We are focusing transformation in the slash. The activated slash plant is going to transform in granular slash. What means that? The granular slash help to has higher slash specific weight and certain properties. The granular slide has a high sedimentation rate of an SBI less than 30, biological phosphorus removal without metal salts, and advanced nitrogen removal in oxygen tank. Why we are doing that? Because we are looking to reduce different problems that we have in the plants. We are going to reduce the slash production. We are going to increase the capacity and the quality of the water. We are going to help to reduce the chemical consumption. We are going to adapt our technology to any activity slash wastewater treatment. Okay. How we can help to different companies to get different goals? We can focus in the main problem that the plant has in this moment, like capacity in the plant, of quality of the water, to the production of the slash and capacities. We have the opportunity to focus in different goals, or you can balance the different objectives that you have in the plan. Okay, and how we can implement this technology? We have one part hardware, another part of software. The hardware is a hardware company, is a floating steel device. We are going to implement this technology in the biological reactor. The characteristic of this device, you can see here in the picture. The physical characteristics, the dimension is 2 meters by 2 meter by 2 meter. The weight is only 600 kilograms. Energy consumption is low. It's only 5 kilowatt-hour by day. And we integrate this hardware with our platform. This platform helps to connect different devices in the plant, and we are going to control the process with the remotely. Our process is with the control room, and we are going to control the process in order to look for the granular slash in the process. Okay, and how is we are going to work with this technology? We are going to connect the device with the aeration devices, with the mixer, with the recirculation pumps, and we are going to control these devices. And we get information from the pump, from the SCADA for different device, and we are going to decide the best moment to start off the aeration devices in order to get the best level of the oxygen in the biological reactor. Okay, this process help to transformation and the flow get inside of the Oblysis device and going to transfer the slash. Okay, what kind of plant we are implement this technology? We can implement in conventional activated slash plants. We can implement this technology in carousel system or MBR with external filtration. The tank, the level of the size of the biological reactor, 20 to 5 to 6 meters is is okay for implement our technology. About the aeration system, we have a different plant with blowers or turbines or submerged aerators. Okay. About the size, we don't have about the size because we can adapt or we can implement the different devices depend of the characteristic of the plant. We have to check that what is the necessary, how many devices is necessary in the plant. About the type of the wastewater, the urban or industrial is possible to implement the technology. Okay, we have different conditions that we needed to get the transformation of the slash. The main characteristic that we have to the level of the oxygen that we have in the biological reactor. We are operating around on the 2 ppm of dissolved oxygen. Okay, and we have to review the technical point of view of the plant, but we are going to check if necessary to adapt. But it's usually that you don't have to do any adaptation in the plant. Okay, you can see here some videos in the process, the changing the slash. Okay, is going to transformation and going to help to different goals. Okay. We are going to work with the platform. This platform helps to the client to control the different parameters that you want to control, because if you are focused in the characteristic of the effluent, we can review the parameters and control what happened in the plant, what happened with the different goals, because we have to identify the baseline that we are going to work or when we are going to start the project, and to follow the different objectives that we have. And the platform helps to operate the device and to look for the best opportunity to focus on the operational in the plant. Okay? How we can do this kind of project? The first step is we have to know the plant, the characteristic. We have to identify different parameters and identify different goals that you have in your plant. Okay. Then we have to prepare when we know that this plan is possible to implement the technology. We are going to prepare to the plant to install the device. Okay. We can identify the different information of the plan. We can have the definition of the different integration or system or devices that we have in the plant to get information. Okay. After that, we have the information. We have to install the device in the biological reactor. It's so easy. It's only you have implementation this technology in 2 or 4 hours. Okay. You don't have to do any modification in the plant, infrastructure modification. We have to connect to the aeration devices, and we have to calibrate. We needed 2 or 3 weeks to calibrate the device, and then we can start the operational to the Oblysis technology and focus in the different objects that we have. Okay, this device. We have a services. We don't solve the device. We have a services. We have a model, the service feed. We have defined the different objectives about the quality of the water, or maybe we have problem with the operation cost. Okay, we can work in order different objectives too. Okay. We have different projects here in Spain, in Italy, in Portugal. We are looking for other countries to implement this technology, because we want to give the opportunity to understand how this kind of technology help to the plant. No? This is the idea. The idea is to, for For example, in this kind of plant, we have different objectives. Here in Spain, we have problems with the high cost of the energy. In Italy, for example, the price of the sludge management is so high. It's the new regulation we have with the effluent is important to control the quality and parameter of the water parameters. Okay, I thank you, everyone.
Good morning, everyone. Thank you for all attendance, and thank you to the Spanish Business Council for organizing this webinar. I'm Salvador Muñoz. I am process engineer in SENER, and we are going to talk about an efficient and sustainable design and operation of desalination plants. This will be applicable to any kind of asset, energy plant, sewage treatment plants, desalination plants, and so on. Well, first of all, I want to see some of our experience in KSA and Middle East. This is our global footprint. We are present all over the world. In Middle East, we have permanent offices in Emirates, Saudi Arabia, Qatar, Egypt, etc. We have been working with NEOM in different projects, developing materials and specifications and product in contact with water for treatment plants, sewage treatment plants, desalination plants, transmission lines, pumping stations. Also for specific projects for water bottling and treatment plants. Also helping NEOM for this integrated water management control system. I want to say that SENER is not an EPC company for implants, but an engineering firm providing engineering services to the EPC companies in bid phase and detailing and construction phases. Okay. Well, now we are going to talk about the water and desalination plant efficiency and sustainable design and management. Okay. This is applicable to any kind of plant. ESTP, independent sewage treatment plant, independent water treatment plants, transmission pipelines, water storage tanks, etc. Rather than talking about the reverse osmosis desalination process that is well known and in continuous improvement of this efficiency by equipment designers and manufacturers, I'm going to talk about the management of a desalination plant as an energy asset from the design phase and also in plants already in operation, and how we can optimize the design of the plant and the operation of the plant from an energy optimization point of view. These plants are intensive consumers of energy. This is well known, and our focus is to try to optimize this mix. First of all, the traditional design procedures, well known, this habitual design process calculation, 2D and 3D plans. This is the initial design procedures. Then the renewable energy has been implemented in the plants. Also, this is a second step to the sustainability of the plants. Then the BIM methodology has been applied for years in plants for the whole life cycle of a plant, from the design to the end of its life. Some example. Then the next step is to use the digital models of the plants digital twins, control centers, intelligent control center, using Internet of the Things, big data, and all of these new technologies. But we want to take one more step toward the sustainability of these desalination plants. And within this must be the optimization of the energy consumption. To do this, SENER has its own tools, but applicable in the design phase and the plants in operation. This is the EMS and the DAE system. This is a brief view of the BIM process. BIM is not a software. This is well known. This is a method of collecting and sharing facility information. So the BIM model is in fact a database composite of information for many sources. This database becomes more complete as the project progresses and is a live model. Well, the BIM is applicable from the preliminary design to the detailed design, construction, and operation and maintenance. Well, the application of the BIM methodology helps to minimize errors in the design, construction, and operation and maintenance, leading to savings in material and energy, which contributes to the sustainability of the desalination plant. This is a case study. This is the Tahuila desalination plants in tender phase. We applied the BIM methodology for this design. And the next step after the BIM methodologies is the digital asset management. And this digital asset management has a lot of items and topics to take in account. So it is really complicated to manage this manually. You can see manually. So we use some tools, big data processing, to take to have a digital twin of the plant and an advanced control center of the plant. So the new concept of digital asset management is focused on continuous monitoring, sensor satellite, the PPs, and human contribution, which are the knowledge of the actual condition of the water treatment plant's predictive maintenance with clear benefits and operation reliability and the availability of the plant, life cycle cost saving through the optimization of the maintenance activities and safety, as the number of incidents will be reduced. Okay, our next step, most advanced step now, is applying in plants. This is a traditional scheme of a desalination plant. Desalination plant is provided by an external electricity network outside the plant battery limit. This is the first approach, the traditional approach for these plants. Then the renewable energies will be applied inside the battery limit of the plant as photovoltaic plants. We can use also eolic wind energy, onshore or offshore. And we have another available renewable energies, maybe as hydrogen, green hydrogen. The desalination plants are installed on the coast, so it is possible that there could be use. They are close to ports where the hydrogen is transported for other uses and take the advantage of the supply to the desalination plant. Using through fuel cells, we can generate electricity inside the plant using this green energy. Also, energy accumulation are necessary. The renewable energies are not continuous. Mostly photovoltaic and aeolic is not continuous, so some accumulation are required. Another option is to generate green hydrogen inside the plant using part of the pyramid of the first arrow pass through a second pass and an electrodeionization. To be used this ultra pure water in electrolyzers, hydrogen electrolyzers, that through the fuel cells we can provide electricity to the plant. So we have a mix of many possible energy sources, and our focus is to optimize this mix of energy. This is not to think about we are going to install the maximum available surface for photovoltaic panels, or the maximum available surface for aeolic energy, but to optimize any kind of this energy and its accumulation to find the optimum in the design phase, and then in the operation phase to monitoring in real time the consumption of any kind of these energies. So this is the tools we use, the EMS and the DAA. The DAA is applicable in the design phase and the EMS in the operation phase. So we have a mix of energies. We generate these graphics, and we find the minimum and the optimal combination of these different sources to optimize the photovoltaic surface, the aeolic surface, the size of the batteries, the accumulators, or even if we're using the green hydrogen to optimize the size of the fuel cells. So as I said, there is applicable in the design phase, and the EMS is in the management operation strategies in real time. This is a tool. As I said, we find the optimum in the design phase. We have the preliminary design, the basic design, and considering all the factors that affect to the consumption, also the energy availability, the weather, any kind of criteria that can affect this mix of energies, and sizing the optimum equipment and installation of these energies. This is a real application of this system in a desalination plant. This is a small desalination plant combining geothermal energy. We can include also geothermal energy in these tools, photovoltaic energy, and fuel cell. And this gave us the optimum size of each kind of energy source and its accumulation. Then the EMS, the energy management system, is a tool which provides an optimized service for energy use in real time, depending on the climate conditions. If there is sun or not, more wind, less wind, hydrogen available in real time, the system optimize the mix of the energy used in the plant. So this is a predictive optimized energy program. This have a lot of layers with the objective to optimize in real time the energy consumption of the plant. EMS include a lot of inputs. We can use also for electrical vehicles, virtual power plants. This is applicable, Respira is applicable for another kind of infrastructures. This is the visual aspect of the EMS interface. And that's all. Thank you for your attention.
Thank you. Let's now, if someone has some question, this is the time to do it. I have through email some people which is interested in asking, so I will proceed. For INDRA, is this main feature located at the current project location?
It's a technology we have implemented in different countries. In this moment, we have to implement in Spain, in Italy, and Portugal. We are looking the opportunity to presentation to know that the other country know our technology, because we have a good result. It's this opportunity to know new technology. Okay, this is we're looking for this in this moment for this way. Okay.
Okay. Thank you. For ACCIONA, which was the main challenge ACCIONA faced and I facing for doing projects in KSA?
Yeah, I understand. Thank you very much for the question. I think the biggest challenge we had here is to attract the people and to retain the people and the talent. And in this regard, what I would recommend the people is not to pay attention only to the opinators we have all around the world and in Spain, that some of them are not able even to locate Saudi Arabia in the map, but to come to Saudi, to see how Saudi is today, how interesting is not only to work, but to live here in this country. This country went through, let's say, tremendous transformation in the last 10 to 15 years. And you will see what is the real Saudi, how comfortable you will be here. And maybe with this, we can attract more and more people to this country.
Thank you, Julio. And another one for ACCIONA. We have seen that what ACCIONA has done and is doing for help to achieve 2030 Saudi vision. But what about the future? What is the strategy of the company for the upcoming years?
Thank you very much. Well, because of the attractive pipeline that we have here in the country with number of projects, we have to consider that Saudi doesn't have any natural resources for water, and in the core of ACCIONA, Agua is the supply of affordable and sustainable water. For sure, we are going to remain here. We are going to be working very close with all the water authorities to provide a better services to the population, and as well to become more and more local, meaning that we are going to keep establishing our company, and we want to see ACCIONA not only as an international company working in Saudi, but as a company that has a very strong and long-lasting ties with the country in the long run.
Okay, I think there's no questions. No more. I think so. Okay, thank you all of you for your collaboration today, for this very clear information with all your knowledge, and hope to see you soon in person. Okay.
Sure.
Thank you so
very
much.
much.
See you, Marta.
Thank
Thank
you.
you, Juan.
Bye.
Bye.